Hello students, Callie Daniels here. In this video we will solve applications of quadratic equations. Our steps that we'll take to solve an applied problem are to step 1, read carefully. Step 2, assign a variable to represent the unknown value. Use diagrams, tables, or pictures as needed. If necessary, express any other unknown values in terms of the variable. Step 3, write an equation using the variable expression or expressions. Step 4, we will solve the resulting equation. Step 5, state the answer. Does it seem reasonable? And step 6, check the answer in the words of the original problem. So here we go. In example 1, a hardcover book is 2 inches longer than it is wide. The area of the cover is 48 square inches. We want to find the length and the width of the book. So, we might be talking about, a book like this that has a width and a length that is longer. Now I'm going to draw a picture of a rectangular cover of a book. And we've got our length and the width. Now, reading back through the problem, we know that a hardcover book is 2 inches longer than it is wide. So if we let x represent the width, then we can represent the length as x plus 2. And that's probably the most efficient way to define your variable and then represent the other unknown using that same variable. We know that the area, so if we were going to color the surface of that book, that area is 48 square inches. Now I'm going to use the picture to define those variables. And now let's see if we can convert what we know into an equation. We're at step 3 right now. Well, we know that the area of a rectangle is length times width, and that's what we're dealing with, a rectangle. Our given area is 48 square inches. The length of this book we've defined as x plus 2 and the width x. Now the hard part is over. Let's solve the equation. Distribute on the right to obtain x squared plus 2x. Let's subtract 48 from each side so we can write this equation in standard form. And we'll solve this resulting quadratic equation by factoring. It factors x plus 8 times x minus 6. Zero factor property, x plus 8 is 0, or x minus 6 is 0, yielding x equal negative 8 or x equals 6. Now, since x represents the width, we can determine that negative 8 inches does not make sense for the width of a book, but x equals 6 does. So if the width is 6 inches, then the length of the cover of this book is 6 plus 2, or 8 inches. And there we have our answer. Make sure you apply the units to your answer, in this problem inches. And a quick check, we can see very quickly that 8 times 6 does indeed give that surface area of the cover of the book 48 square inches. So this checks out just fine. Let's look at another one. Example 2. We want to find 3 consecutive odd integers such that the sum of all 3 is 42 less than the product of the second and the third integers. Well, before we get started, let's make sure we understand some vocabulary used here. For example, the set of integers can be described as ellipses. So dot, 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 -3, -2, -1, 0, 1, 2, 3, and so on. And the ellipses are used to suggest that we continue in like fashion in either direction here. So here we've got our set of integers. Now, consecutive integers are integers that occur right in a row, such as -2, -1. Those are consecutive integers. But we want to focus on consecutive odd integers, like 1, jump to 3. Our next odd integer would be 5, then 7, and so on. So we've got our basic understanding of the vocabulary. Now let's define our unknowns. We want to find 3 unknowns here. So let's let x represent the first odd integer. Now x plus 2 is an expression that we can use to represent the second odd integer. For example, if our first odd integer is the number 1, then we would add 2 to that to obtain the next consecutive odd integer, 3. Okay, so x plus 2 represents the second odd integer, and then x plus 2 again, or x plus 4, represents the third odd integer. Okay, so now let's write an equation based on the sentence that we read above. The sum of all 3 is 42 less than the product of the second and third integers. All right, so the sum of all 3, we're going to add x plus 2 plus x plus 4 is, we interpret as the equal symbol, and 42 less than the product of the second and third. Okay, product means to multiply the second and third. X plus 2 times x plus 4, and subtract 42. The sum of all 3 is 42 less than the product of the second and the third. Hard part's over with. Now we simply solve this equation. Combine terms on the left to obtain 3x plus 6. As we multiply on the right, we've got x squared plus 4x plus 2x combined to plus 6x plus 8 and minus 42. Combining terms, we've got x squared plus 6x, and 8 minus 42 is a negative 34. I'm going to move terms to the right in order to write this in standard form. Let's subtract 3x. 6x minus 3x is 3x. Subtract 6. Negative 34 minus 6 is negative 40. And next, let's factor. This is a trinomial with a leading coefficient of 1. So we know our first terms in these factors must both be x. Factors of negative 40 that sum to 3 are minus 5 and plus 8. Zero factor property. X minus 5 is 0, or x plus 8 is 0, which gives x equal 5 or x equal negative 8. Now we may omit that solution option x equal negative 8. Negative 8 is not an odd integer. 5 is, however. And if 5 is our first odd integer, Then our second odd integer is 5 plus 2, or 7. And our third odd integer is 5 plus 4, or 9. And let's just do a quick check and see if this makes sense. If we add them all together, 5 plus 7 plus 9, is that equal to the product of the second and the third? That is 7 times 9 minus 42. And in each case, we're going to obtain the number 21. And that checks out just fine. Okay, always look at your answer to see if it's reasonable. And then if time allows, go ahead and do a formal check like we have done. In example 3, we're going to solve an application pertaining to a right triangle. And a right triangle has a right angle or 90-degree angle. This right triangle, we can see, has a short leg and a long leg. The legs form the right angle, and this side opposite the right angle is the hypotenuse. It's common to use the letters A and B to represent the legs of a right triangle, and C to represent the hypotenuse. Now, in this example, again, the hypotenuse of a right triangle is 3 inches longer than the longer leg. The shorter leg is 3 inches shorter than the longer leg. Find the lengths of the sides of the triangle. Now, the hypotenuse and short leg are both given in terms of the long leg, so I think it'd be best to let the long leg be represented by a variable x. The hypotenuse is 3 inches longer, so we can express it x plus 3. And the shorter leg is 3 inches shorter, therefore we can express it x minus 3. Now we want to find the lengths of the sides of this triangle. And in order to do that, we're going to use our Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared. We can also write that leg squared plus leg squared is equal to hypotenuse squared. And let's substitute our expressions that we have, all right? I'm going to let the short leg, okay, substitute x minus 3, and let's substitute x for the long leg, and x plus 3 for the hypotenuse. I don't know if you can hear my dog over here breathing heavy. I apologize. Let's continue. We're almost done. X minus 3 times x minus 3 plus x squared, x plus 3 times x plus 3, and let's use our FOIL method. On the left we've got x squared minus 6x plus 9 plus x squared. That's equal to x squared plus 6x plus 9. So we've got a quadratic equation. Let's combine our x squared terms here on the left. That's 2x squared minus 6x plus 9. That's equal to x squared plus 6x plus 9. Now when we move terms to the left, 2x squared minus x squared is x squared. Negative 6x minus 6x combined to minus 12x. 9 minus 9, okay, cancels out. Factor out your greatest common factor, which is x. X times x minus 12 is equal to 0. That gives x equals 0, or x minus 12 equals 0. So x equals 0 or x equals 12. Now x equals 0 makes no sense for the length of a side of a right triangle, but x equal 12 does. And that then says that the length of the long leg that was our variable x, and that is 12 inches. Our units given in this problem was inches. And the short leg, 12 minus 3, 9 inches. And then the hypotenuse must be 12 plus 3, or 15 inches. And as a quick check of our answer, let's just determine if the lengths of these sides satisfy our Pythagorean theorem. In other words, is leg squared plus leg squared equal to hypotenuse squared? Is 144 plus 81 equal to 225? And yes, it is. That is a true statement, and so we're pretty confident that we've done our work correctly. Now, one thing to notice about use of the Pythagorean theorem, addition is commutative, and so it does not matter which of these we let represent A and B. Okay, but what is important is that the hypotenuse, which is always your longest side, is substituted on this right-hand side as a term by itself. We sum two smaller things to get the larger thing, or larger side of a triangle in this case. So just remember that. Last problem here, example 4, we're going to look at an object projected upward from ground level with an initial velocity of 64 feet per second. Its height h in feet t seconds later is h equal negative 16t squared plus 64t. Now this term, negative 16t squared, is a result of gravity, and it's going to pull that object back down to the surface of the earth. And 64 is the initial velocity. Now, in part A, after how many seconds is the height 48 feet? So that's a value for height. And therefore, in this formula, we're going to substitute that in for h. So 48 is equal to negative 16t squared plus 64t. I'm going to move terms to the left-hand side so that my t squared term is positive. 16t squared minus 64t plus 48 is equal to 0. Now we want to factor this, but I see a common factor in here among these three terms, 16. Rather than factoring 16 out of there, I'm just going to divide 16 into both sides. So we're going to divide 16 into each term on the left. That gives t squared minus 4t plus 3, and that's equal to 0. Now this is going to factor nicely. T minus 1 times t minus 3 is equal to 0. And using our zero factor property, t minus 1 is 0, or t minus 3 is 0, t is 1, or t is 3. Now, in several of our previous problems, we've gotten we omitted, deleted one of our possible answers. But in this case, we're going to keep both of those answers. And let's just make some sense of this. If this object is projected upward from ground level, at some point, it's going to reach its maximum height and then fall back to the earth. And if we think about a height 48 feet, then that object is going to pass through 48 feet on the way up and then back through 48 feet on the way down. And it makes sense that after 1 second, it passes through that height of 48 feet on the way up, and after 3 seconds, it's falling back toward Earth and passes through 48 feet again. So both of these answers make sense and are solutions, okay, to the equation that we've set up. Part B, the object reaches its maximum height 2 seconds after it is projected up into the air. What is the maximum height? Well, 2 seconds is time, and so we're going to substitute that for t. H is equal to -16 times 2 squared plus 64 times 2. And calculating here, 2 squared is 4, times -16 is -64. 64 times 2 is 128, and 128 minus 64 is 64. So back to our figure, okay, the maximum height after 2 seconds, that maximum height is 64 feet. And go ahead and apply your units to that height value. Now, lastly, after how many seconds does the object hit the ground? So, in other words, okay, it's going to rise, hit its maximum height, and fall back to the ground. And so we're concerned about this point right here. And when that object falls to the ground, the height is 0, isn't it? And so in our formula, we're going to replace h with 0 this time. 0 is equal to -16t squared plus 64t. And let's see, I'm just going to go ahead and factor out my greatest common factor here. I'm going to factor out -16t times t minus 4. So -16t equals 0, or t minus 4 is equal to 0. Dividing by -16, t is 0. Adding 4, t equals 4. So what we see happening here is that at time 0, the object is still on the ground and it hasn't been projected upward yet. So at that point you might think of as 0 seconds, height 0 feet. Okay, so it's really not the result that we're after. Okay, our question is, when does this object hit the ground? That's after it's gone up and come back down. Okay, and right here we can think of that as after 4 seconds, it has fallen back to the ground and the height is 0 feet. So our answer to this part is 4 seconds. Okay. All right, so that's example 4. These were all examples and applications that resulted in quadratic equations. Okay, remember to follow your 6-step process. Be sure to define your variables and check your answers. Good luck with those.